Hello everyone, my name is Harshita Sonet. Today we will discuss this assignment questions. Now, first is explain the difference between supervised and unsupervised learning. Provide examples of algorithms for each type of learning and discuss scenarios where each would be appropriately used. First is supervised learning. Supervised learning is a type of machine learning where we train the model using labeled data. Labeled means each example in the dataset already has the correct answer. सुपरवाइज लर्निंग में मॉडल को हम लेबल डेटा देते हैं और उसको पहले लेबल मतलब कि ऐसा एग्जांपल डेटा सेट में जिसके पास पहले करेक्ट आंसर है then it will identify the relationship between input and output, then it will predict the answer from this learning. It is just like studying with the help of solved examples in textbook because we already know the right answers during training. Okay, now unsupervised learning, on the other hand, works with the data that has no labels. In this unsupervised learning, we don't give the labels data that it has no labels. Okay, the model is not told what output should be. It tries to understand the structure of the data by itself. In this learning, the model automatically or on its own find the structure or grouping of the data on its own. We don't told like what should be the output. This type of learning is mainly used for grouping pattern detection. It generally detect what the pattern is, what the structure is, and understand the hidden structure within a data. It is like exploring a new topic without any guidance, trying to find patterns on your own. Examples of algorithm. Supervised learning algorithms. First is linear regression, used for predicting continuous values like house prices or temperatures. House prices. Like we know, we predict the prices of house from like we have a table in which it is mentioned that how much BHK and how much square feet flat or house has what the price. Then we will predict the data. Okay. Now, in this, we also predict the temperatures. Second is logistic regression, used for binary classification problems such as spam detection. In logistic regression, its example is email. We generally uh, detect that the email is spam or not spam. Its output is generally in the form of 0 or 1. In this regression, we find out the category and class for the dataset. Decision trees used for both classification and regression tests. In a decision tree, generally a tree is made and it asks some questions like if age is above 18 or below 18, then the tree will expand according to the answers, either in left or either in right. Now the fourth is support vector machine, used for separating data into classes using hyperline. Hyperline plane is basically a boundary in which we separate the data into classes. Can nearest neighbors classify data based on the closest training examples. In this, for the data, we need to find out the new data. We basically find out the distance through Euclidean distance formula, and then we set a k value. Okay, then we will find the value on which the k value is nearest to the. Then we predict some 1 to 2 values that can be the answer. And sixth one is appropriate algorithm, used for finding associations and frequent item sets in transactional data. Now, unsupervised learning algorithms. In this, K means clustering, grouping data into specified number of clusters based on similarity. Clustering में between data, if any similarity, then we group them into the clusters. Hierarchical clustering. Build a tree-like structure to represent data grouping. In hierarchical clustering, or we build a tree-like structure. It can be bottom to up or up to bottom. Principal component analysis is used for reducing data dimensions while retaining important features. Okay, appropriate use scenarios. Uh, Here we will discuss that where can be supervised learning is best to use and where the unsupervised learning is best to use. In supervised learning, you have label data. You want to predict or classify future outcomes. In supervised learning, अगर हमारे पास लेबल डेटा है या फिर हमें कोई फ्यूचर आउटकम्स प्रेडिक्ट करने हैं या क्लासीफाई करने हैं तो हम सुपरवाइज लर्निंग का यूज करते हैं. एग्जाम्पल, प्रेडिक्टिंग स्टूडेंट ग्रेड्स बेस्ड ऑन स्टडी आवर्स. लाइक कोई बच्चा कितने घंटे पढ़ता है तो उसके क्या ग्रेड्स आ रहे हैं, ये हम प्रेडिक्ट कर सकते हैं. आइडेंटिफाई whether an email is a spam or not. This is the example of logistic regression. In this, we will get the output in the form of 0 or 1 because we need to identify that whether the email is a spam or not. Third example is detecting disease from medical images. Okay, unsupervised learning. The data is unlabeled or unstructured. जब हमारे पास डेटा अनलेबल्ड या अनस्ट्रक्चर होता है तो हम उन अनसुपरवाइज लर्निंग का यूज करते हैं. जब हमें किसी डेटा में ग्रुपिंग करनी होती है या कोई पैटर्न फाइंड आउट करना होता है तो हम अनसुपरवाइज लर्निंग का यूज करते हैं. इसका एग्जांपल है कस्टमर सेगमेंटेशन बेस्ड ऑन बाइंग हैबिट्स, ग्रुपिंग सिमिलर न्यू आर्टिकल्स और प्रोडक्ट्स. लाइक कोई आर्टिकल में कुछ सिमिलैरिटीज है तो हम उसे अलग ग्रुप कर देंगे, किसी प्रोडक्ट में सिमिलैरिटीज हम उसे अलग ग्रुप कर देंगे. डिटेक्टिंग अनयूजुअल पैटर्न्स इन नेटवर्क ट्रैफिक. Okay, now we will discuss the second question. Describe the concept of hypothesis space in machine learning. Explain the algorithm find S. Find a hypothesis by find S for the following instances in training set. Okay, this is the set where we have origin, manufacturer, color, decade, type, and class. Okay, concept of hypothesis space. In machine learning, a hypothesis is a possible explanation or function that maps input attributes to output labels. The hypothesis space is the set of all possible hypotheses that the learning algorithm can choose from. For example, if you are trying to predict whether the car is positive or negative based on its attributes, such as origin, color, or type, then each possible rule or combination of these attributes form one hypothesis. The goal of the learning algorithm is to find the most suitable hypothesis from this space that correctly classifies the given training examples. Find as algorithm. The find as algorithm is a simple concept learning algorithm used to find the most specific hypothesis that fits all positive examples in the training data. It assumes that all instances are noise free and that there exists at least one positive example. In this algorithm, we only take the positive examples and we will ignore the negative ones. Now the steps are initialize the most specific hypothesis H to the most specific value possible. Now the second is for each positive training example. Firstly, we will just take whose origin or which is positive. Okay. Now compare this example. We will always compare that example to the current hypothesis. We will iterate this process until the all hypothesis will be covered. If the hypothesis does not cover the example, generalize it just enough to include the example. Ignore negative examples. We will just ignore the negative examples. Then continue until all examples are processed. Now, this is the set. Step by step, we will try to find out the answer. First, positive example. Japan. Its set is Japan Honda Blue 1980 economy. This is the first example. Now the second. Second was is negative, so we will ignore it. Third positive example. Japan Toyota Blue 1990 economy. Now we will compare this with the first example. Japan is same. Honda Toyota it's different. Blue is same. 1990. So decade is also different and type economy is same. Okay. Difference found in manufacturer. Honda and Toyota are mismatched, decade are mismatched, so generalize differing attributes. So in wherever we find the differences, we will just put out a question mark there. Okay. Now fourth example, it is negative, so we will ignore it. Fifth positive example, Japan Honda White 1980 economy. Compare with H. We will compare this with the third positive example. Difference in color. So here is the difference in color. We will put out question mark there. Panel hypothesis found by find S. Okay. Now the hypothesis remains Japan question mark economy interpretation. The final hypothesis suggests that if a car is from Japan and its type is economy, it will be always classified as positive. रिगार्डलेस ऑफ मैन्युफैक्चरर कलर डिकेट। मैन्युफैक्चरर कलर डिकेट कोई सा भी हो, अगर वो कार जापान से या उसका टाइप इकोनॉमी है, देन वी विल ऑलवेज क्लासिफाइड इट एज पॉजिटिव।